In this video, we will be discussing two separate shapes. The first being the cone. A cone is identified by a point at one end, and on the other side it has a circle. And the cylinder, which is denoted by a circle on one end and a circle on the other. There are some unique things that tie these together, such as they are of the same height. And we can also notice that they have the same size circles at both of their circle ends, meaning they have the same radius and they have the same diameter. But do they have the same volume? And that's what we're going to explore. So let's take a look at the cylinder, for example. If I was to fill up this cylinder full of water, like so, we could think about the water as its volume. So for example, the amount of water that I pour into the cylinder could be considered the cylinder's volume. The amount of water is its volume. And we're going to be comparing that to the volume of the cone. Now, if these two objects had the same volume, I should be able to take the volume of the cylinder and pour it into the volume of the cone. If the volume of the cylinder was bigger, I would have some volume left after pouring it into the cone. And if it did not fill up the cone, then the cone would have a larger volume than that of the cylinder. So let's take this water and see what happens when we pour it into the cone. You'll notice that the cone is approaching full, but the water in the cylinder remains. So we can say that the volume of the cylinder and the volume of the cone are not equal. In fact, the cylinder is bigger. But how much bigger? So let's explore exactly what would happen if I was to pour volumes of the cone into the volume of the cylinder. So let's start by emptying both of our volumes. And instead of taking the cylinder and filling up the cone, let's take the cone and fill up the cylinder. But first, let's take a guess. How many cones should it take to fill up the cylinder? Let's find out. I'm going to take my cylinder and I'm going to add some water to it. And I'm going to do my best to make sure that it's very full so that we can illustrate this. So we have our first cone worth of volume and we're going to pour it into the cylinder. We have our second cone of volume. And we are going to pour it into the cylinder. We have a third cone of volume. And we are going to pour that into the cylinder as well. You'll notice that the volume of the cylinder is now full. My question to you. We could say that there is 3 cones of volume that it takes to fill up one cylinder. What would that say about the volume of the cone when comparing it to the volume of the cylinder?